Welcome, I'm Kelly Fiedler, Chief Marketing Officer at RSA, and I'm excited to be moderating our panel today on bootstrapping trust with verifiable credentials. I'm pleased to have three fantastic panelists with me today. Welcome, everyone. Why don't we go ahead and start, and I'll have you each introduce yourself. Tell us a little bit about you, the company you're with, your role. And why don't we start with you, Kevin?
Thank you very much, Kelly. So my name is Kevin Bowers. I lead RSA Labs here at RSA. And RSA Labs is the research group inside of RSA. So we tackle things that are outside the scope of the existing products, whether it's a long-term project that needs attention, or it's something that's too risky for the product to take on, or it's a new technology, a potentially disruptive technology, as we'll be talking about today with verifiable credentials. And so that's where Labs gets involved. And Brian, who will introduce himself in a moment, is our chief researcher on that topic. Justin, over to you.
Thanks, Kevin. Thanks, Kelly. My name is Justin Bingham. I'm the Chief Technology Officer at Genero Digital, and I'm also a contributing author and editor of the Solid Open Standard, with Solid, we're using decentralized patterns to give people control of their data. And when you start solving these kinds of patterns and problems, you end up creating new problems that you need to solve. And verifiable credentials is a key piece of the solution. And we're going to talk a little bit more about that in a bit. At JD, I oversee our strategic technology initiatives, and most specifically, creating the software and technology that applies these decentralized patterns and verifiable credentials in the field today.
And lastly, I'm Brian Mullins. I'm a developer at RSA. I work with Kevin on the RSA Labs team, and for the past year or so, I've been leading development efforts around exploring verifiable credentials and building a set of tools and services around them.
Great. Well, welcome, everyone. So in your introductions, you mentioned verifiable credentials. Why don't we start with what exactly that is? So how do you explain verifiable credentials to people who are new to the technology? Brian, why don't we have you start there?
Sure. So let me start with just a simple definition of how I think of it. And then I'm also going to speak to, we only have a couple of slides today, so I want to speak to one of the slides that you'll invariably come across if you start reading about verifiable credentials. So first with the definition. So the way I think of a verifiable credential is it's just an attestation. So any person, anything can make an attestation. And in this case, that attestation is digitally signed. So we have this cryptographic attestation, which then you can hold and you can present to somebody else, which can be instantly verified by anyone. So I know that's a little bit dense. So the way I like to break it down is with an example. And in the example, I'll speak to this slide as well. So my go-to example is actually automatic bill pay. So if you reflect on how this works today, the state of the art is actually pretty clumsy, pretty slow, pretty inefficient. So the way it works is you log on to your online utility provider and they ask you for a bank account number. Now, because you can provide any bank account, they need to verify that you actually, this one is yours. So what they'll do is they'll make a couple small deposits into your bank account. You need to wait, if you're lucky, a day. If not, it can be a couple days. So then you have to, sort of stop what you're doing, wait 24 hours or more. Remember to log into your bank, go get those deposit amounts, log back into your online utility provider, and then enter the amounts. And so, here's this use case where both sides have strong incentives where they want to make automatic payment simple and easy. But it's hard today. It's not quite possible. So instead, consider now if we use this new thing called verifiable credentials. So the way it would work is when you set up your bank account, you'd log in, you'd authenticate yourself, And they would issue you a verifiable credential that would attest to your name, which bank it is, and the bank account number. So in that case, the bank is the issuer and you would be the holder. Later, when you're asked by your online utility provider for a verified bank account, you would present that credential to them, and they'd be able to instantaneously verify that, okay, here's a credential issued by Bank of America, bank account number 1234. And they can make sure that your account is in good standing, and they have a strong assurance that that is in fact a bank account is yours. So I think that's an example of the issuer would be the bank, like I mentioned, you would be the holder. And in this case, the verifier is this utility provider. And then tying it all together, which I won't get into, is sort of this public data registry, sort of the fabric. Providing some of the definitions and also some of the public data needed in order to verify that digital signature. So you can see that the technology is pretty simple, but there is an ecosystem here, and it's important to understand the role of each part.
So I usually like to explain verifiable credentials using something that people understand today. So most of us have a wallet or a purse, and you have inside of your wallet or in your purse, you'll have things like driver's licenses or health ID cards or credit cards. And each of these things are issued to you by your bank or your state government or your federal government. And you walk around and use these things to make purchases or to prove that maybe you're old enough to buy alcohol or that you're able to drive. And that's worked pretty well for a fair amount of time. But over the last couple of decades, we've started to use something called the internet a whole lot more for just about every facet of our lives. And those physical transactions that we used to have turned into predominantly digital ones. But our physical wallets, our physical credentials haven't really made the journey with us. So if you want to buy something off a website, you can't just shove your credit card into the screen. If you want to prove that you're old enough or that you're a valid citizen, you don't necessarily have the ability to kind of tap on your computer with that information. Just have your application recognize it. And we need a digital way to do the same representation. So with a verifiable credential, your local government may issue you a verifiable credential. And in Brian's example, they become the issuer. You get a credential that may say that you're allowed to drive in your state. And over time, we'll have more and more infrastructure around us that's digital, that knows how to understand these credentials wherever they're presented, whether it be if you drive too fast and get pulled over, or if you're in a store and you want to be able to prove that you're able to buy alcohol, or any other kind of scenario where you may want to claim something and have someone issue you proof of that claim.
Yeah, so I think, Justin, you've got a great way of thinking about these verifiable credentials as replacements for physical things that we carry around today. What gets me really excited about the technology, though, is one step beyond that. Where do we go next? Not for replacement for things that we already have, but as new things that we've never had before. Brian gave an example of that, right? When he talked about the bank account, right? I don't have a physical credential that shows I own a bank account, but that's something that's easy to capture with a verifiable credential. And so I think there's a number of other use cases like that that we can start to explore. So you start to think about, proof of residency, right? I had to register my daughter for kindergarten, and I had to show up with, 2 utility bills and a mortgage statement to try to prove residency, right? This is another cumbersome process that, we've worked our way around, and it generally works. But if we could replace it with a verifiable credential issued by my city or my town that says, you are a resident, well, that would make the whole process so much easier and so much simpler. And, the list of things like that goes on and on. You start to think about the remote onboarding use case. And, given the global pandemic that we're in, people have started to do a lot more remote onboarding. Well, now I need to be able to show up and I need to be able to prove things about myself. My resume or my CV is not verified. There's no way for me to know if any of those statements on there are true. But imagine if it was. Imagine if I could prove where I had worked before, which courses I had taken, which certificates I held in a digital form. That would make remote onboarding significantly easier. My wife works in healthcare, and there the problem is exacerbated, even more. Now you're talking about state licensures and insurance and board certifications. And in that case in particular, when a new physician or a new medical provider is onboarded, they're hired by the hospital, but they can't go see a patient for 3 months, sometimes 6 months, because they have to go through this whole credentialing process. They have to make sure that all of those statements that the practitioner has made are actually in fact valid. They make phone calls and they interact with websites to make sure that these statements are all true. Well, what if I, as a physician, could show up with all that information in verifiable form and hand it over? Now all of that can happen seamlessly. It can happen easily, and we can get to a place where a lot of these things are much more easier, much better designed for the digital world that we live in. And I think that's the promise of verifiable credentials, is allowing us to capture things, to prove things, to bootstrap the trust that we need in these relationships through statements that can be immediately verified. That's really the promise that's offered here.
Thank you. Thank you all. These are great examples that really brought the technology to life. So I'm curious to know, how are your businesses getting involved with verifiable credentials? Maybe Brian, if you could start and talk with me a little bit about how RSA and RSA Labs specifically is getting involved.
Sure. So as you heard Kevin speak, we at RSA think that verifiable credentials have tremendous potential. We think that using them, we can transform a lot of existing business processes to have a better user experience, or even reducing the chance of fraud. Think about all the different institutions that issue either a degree or a license of some kind. In addition to creating these new processes, these new user experiences that just previously weren't possible. Tearing down some of these boundaries that exist between either companies or institutions. So we're very excited at the promise of this technology, but the complication is that currently utilizing these tools requires quite a bit of expertise. So you need some security expertise. You need to be up on the latest specs around verifiable credentials. You might need expertise around decentralized identity. And so it's sort of unrealistic to expect that all the different businesses that might be able to leverage this technology to be able to have the resources to go and build out that expertise. So our vision here at RSA is to build out a set of services and tools around this technology so that those companies don't need to. So one of the terms that I like that you'll hear Amazon use to describe their AWS offering is undifferentiated heavy lifting. So in the case of AWS, they provide the undifferentiated heavy lifting regarding cloud infrastructure. So likewise, here our vision at RSA Labs for verifiable credentials is building out the undifferentiated heavy lifting around verifiable credentials to allow you and your business to focus on your problem and not so much the minutiae and technical complexities around the protocols and other things related to verifiable credentials.
So at Genero Digital, as I mentioned in the introduction, we've arrived at the work with verifiable credentials through a need based on other work that we've been doing over the last several years in giving people control of their personal data using open standards and applying that to real world scenarios. So in the open standards that we're working on, principally, we've been working with a standard called Solid. And what Solid lets you do is give people what we call a personal online data store, which is like a personal web server for your data. And the idea is that instead of your data living in a bunch of different places, it's able to live in your personal data store where you have control of it, over it. You can consent to allow other services and applications to access that. So this introduces a new type of of problem. So the first thing that we needed to do was get existing systems and infrastructure to know how to talk to these decentralized data stores. And we've developed technology that we call Transform that allows these two worlds, the existing enterprise infrastructure and personal data stores, to be able to send data freely between each other so that you can seed these stores with data and make them useful. So that's problem number one. We've developed technology for that and pioneered a lot of the open patterns and standards to make that interoperability work. Now, the other thing is when someone has data in a store that they control, they want to put it to work on their behalf, meaning they want to allow other services or applications to use that data. And we've been working specifically in health. So we've got information coming in from clinical systems. We've got information coming in from medical devices. We have been working with real patients in the NHS to pilot this technology and demonstrate that we can get this data into their pods so that they can use it and use it with other services. But other services, if they're going to give someone some value based on health data that's in their pod, let's just use some examples. If you want to generate an insurance policy, or if you wanted to see if someone might be a match for a clinical trial, you want to have confidence that the information that's stored in this data store that's now controlled by the individual came from an actual clinician and hasn't been possibly tampered with by the person before they submit it. So very hard to put your data to work on your behalf if you control it, if there can't be some proof that it's good data. So we started looking for solutions and finding the work that was being done in the verifiable credential standards to solve them, and have been collaborating in that community pretty actively since, and have been able to apply verifiable credentials to store it alongside clinical data that we're bringing in to show that this data actually came from your health system and it can be proven and verified that it hasn't been tampered with. We've been able to store information in pods like that are approvable credential, that you were issued a certain medication or a certain immunization, and that can be verified. And what's been really exciting for us and in collaborating with Kevin and Brian and their team at RSA is the work that they're doing to make this technology accessible means we were able to integrate with cloud services that they can offer that allow us or others to verify this information that's stored in pods quickly and easily, really completing the circuit and making this ecosystem where people can control their data, put it to work on their behalf, and have that data be trusted a reality.
Yeah, Justin, you talked about the ecosystem, right? And the ecosystem really is, let's go back, a bunch of years to the introduction of the internet, right? That was the first time that there was an ecosystem where security played such a critical role. And it was a pairing up of a bunch of players, but RSA was there to help secure the first version of the internet, to make it useful, to make it helpful. And here we are, that everything you're talking about with decentralized data stores is the Web 2.0. It's the decentralized web that's being born. And we feel that RSA has a role to play again in providing security and making the security easy, making it usable, and making it accessible. And it's all that ecosystem play. It's how do we bring all these people together? How do we allow the thing to grow and bloom into what, take the internet, what it's become? Well, you've got to have that underlying foundational security layer. I think the teaming up of RSA and Genero is really starting to create that opportunity here.
Great, thank you. So clearly there's a lot of work going on around, pilots, use cases, standards, processes, building out the ecosystem. I'm curious, with all that underway, Justin, maybe you can talk to me a little bit about, where are we on the technology adoption curve? And also, you talked about some of the challenges, but what's really standing in the way of broad adoption?
Great question. So these standards and these patterns that we're talking about, whether it's giving people their data or giving people digital wallets with credentials in them, I mean, we're really on the cusp of the future. But I think that as the real world often does, it creates these new factors that sometimes can accelerate things. And we're all globally have been in the midst of this pandemic, which is why we're doing this virtually and not in person. And the pandemic has changed the game in a lot of ways. And one of the things that it's done for us technologists is force us to come up with solutions for decentralized or distributed interaction. And I think one of the best examples of trying to solve a new problem is immunity passports. There has been a lot of attention on how we could solve the problem of giving people proof that they have been vaccinated, or that they have received some kind of treatment, so that they can travel, or so they can do certain things. And I think, serendipitously, these standards that we've been working on now for the last several years to provide digital proof of different kinds of claims have come to the forefront, and really, I think, been rightly looked at as solutions to some of these problems, both solutions to things we're trying to do right now, as well as the toolkit that we can leverage the next time we need something like this as a society. So while these standards are generally emerging and young, uh, current circumstances have really brought them to the forefront. I think it's helped accelerate the adoption curve substantially.
Great. And Kevin, I don't know if you had anything else you wanted to add.
Yeah, I mean, I think you're absolutely right, Justin, that the current situation has accelerated a bunch of this stuff. And you think about the use case I gave earlier around remote onboarding, right? That's not something we traditionally did, but it's something we're going to do a lot more of now, and certainly going forward, right? How we work has changed, and being able to do remote onboarding and present credentials and present proof of things digitally is going to be enormously helpful. I also think you're seeing a number of the big players start to step up and really get involved in this space. Microsoft had a big splash a few weeks back about some of the work that they're doing with verifiable credentials. They're going to allow people to issue verifiable credentials out of Azure Active Directory, and they've open sourced some software to help make this easier. So we can see some of the big players are really starting to get involved and really starting to play in this space. And so while you may not have a verifiable credential in the next 3 months, I think the wave is coming, and there's certainly opportunity for us to take advantage of it and to be ahead of it and be thinking about it. And that's what we're trying to do here.
Great, thank you. So lots of momentum. For people that are watching this panel today and are now extremely interested in this technology, how do they get started?
I think the first thing to know is that the majority of the work that's been happening in designing these standards and designing these technologies is happening out in the open, in public, uh, in different kinds of open source or standards-based efforts. So verifiable credentials, decentralized identity operates in an open community group with meetings that are public and open to anyone, that people should attend and people should collaborate or look at the output of these standards. Similarly, the personal data control technologies that I've been talking about with Solid and Solid Pods, you can go to solidproject.org to learn more about that. There are open public sessions that happen weekly. All of the discussion and collaboration about how we leverage standards to solve these kinds of problems are all open and there for people to participate in, especially developers. It's a pretty vibrant developer community across the board. If you're interested in how these technologies are being applied to solve practical problems in the real world, like what we've done with the NHS and in other parts of healthcare, you can go to generodigital.com to learn a bit more about those specifics and how these different standards really can translate to to actual solutions that you can implement right now.
And I can add to that too, Kelly. So over here at RSA, we're actually launching a brand new site called verifiablecredential.io. And the purpose of that site is to enable people to learn more about the technology, get their hands dirty a little bit, get a feel for it. And if you also have a business case in mind and you want to try and leverage some of the tools and services that we're building out at RSA Labs, please check out Project Mercury, where you can find at mercury.rsalabs.com. And there's a contact form there. So if you fill that out, let us know what you're up to and we'll be in touch.
Great. Well, Kevin, Brian, Justin, thank you very much for your time today. Very interesting conversation. And for all of you watching, please be sure to check out the different URLs that were just presented. Thank you all for your time. This was great.
Thank you.
Thanks, everyone.